Hi. Um, I think I'm audible. So, as title tells, in this stream, we're going to see what are agents and why do we need agents, and basically like everything about agents. At least everything I know. So, yeah, let me start sharing my screen. Yeah. So, from I started my career as intern at uh, from Jan 2025. It's been almost 1.5 years with 1 year full time experience. So I started a quick intro. I started with my internship with working on Python, basically uh, making some LLM calls. So from there, so many things have evolved in past 1.5 year, and so currently, if you see the world is almost there is so much of automation going on in software field, at least to my uh, knowledge of what is happening around the world. So it's pretty decent, good of what is happening. So let's see what is driving behind that and all of that. So what do I put title? Title I'll put as agents and more dot txt. Okay. So the first thing is LLMs. I think we all know LLMs, right? LLMs is, at least back then, LLMs is we ask something, it try doing it from our perspective, or at least it does it from LLM's point of view. So when LLMs are a thing, basically you ask uh, something, and from its knowledge, it answers. When I mean knowledge, it's like training data, which may not be the entire internet data, but a good decent amount of large data. And yeah, so basically it's just a token predictor is what they say. For example, when you say uh, Johnny Johnny, it'll tell Johnny Johnny yes Papa all the time stuff, because it would have seen that Johnny Johnny occurs in that training data. So how does we started using this LLMs? Some tasks like summarization, for example, Slack summarization. There is an incident, and there is an incident that occurred in your one of the product, and a person opened a typed a message that there's an incident on some particular service. So many engineers and managers started discussing on it on the thread. So you came back, and you have to go through all 40-50 messages in the thread by different persons to understand what is happening, what is the summary of that, what exactly happened by the end of conversation, is the what is the issues, or what actually happened, what is being discussed in the thread. So using some APIs, uh, you extract threads messages, send it to LLM, and ask it to summarize. So you say in the LLM call, when you make LLM call from a LangChain library, so you say LLM.invoke, you say you give prompt as you are a good summarizer, all the stuff. Like I will give you some context and refer it in a variable, which you initialize this variable as the extracted data, and you send it to LLM. LLM process that query and the context you give. So it outputs the summary of all the bunch of dump messages that you send. So basically, this is summarization is what we started with. Then slowly, Yeah, these are a little bit broad categorization, so I wanted to. Yeah. Apart from general use case of large language models, for example, how we use ChatGPT and Gemini, apart from that, uh, the first thing that industry started absorbing is this Slack summarization, small applications, because that's a manual heavy process, right? You have to go to 40 different messages on three different point of views and three different persons' uh, thoughts or whatever. So it was useful, it was helpful, pretty time saving, because imagine you going manually going through all the thread and you have a summary of it. So that's wonderful. Second thing is RAG. I won't discuss much on RAG, which I think I'll cover in future some of my future videos if I'm free and willing to cover it. So RAG is basically you give something on a non-trained data or something which on LLM something is not about to able to answer, and LLM does that answer for you. RAG applications does that for you. So for example, you fetch some information, and it's same thing as this thing, but here instead of fetching using APIs, instead of fetching thread messages, there you will fetch relevant information from the user query in a big knowledge source, any knowledge source, big or small. And you ask somebody, you ask LLM key, this is the question, and this is the answer. This is the context for this question. Based on this question and answer, please give me an answer. Based on this question and context, please give me an answer. So RAG does that pretty much. Uh, LLM call similar to summarization only. Uh, Nothing depth involved. So yeah, like RAG was pretty much a big thing, right? So from the concept of RAG itself, vector databases involved. So many vendors, database vendors like Elastic, Pinecone, Fires, so many. I don't even know some of the names. So many vector databases vendors came, and they're like, take this vector database, index your data, and then query the vector database for getting relevant data. Is what that was pretty much happening. And I saw some of my fellow friends also working on that, because everybody has to, they have their requirements, right? So that's how it went. So it was pretty chill until some of the people came saying that what exactly LLMs are more capable of. So with multiple releases, LLMs are capable of executing instead of just processing. They are capable of, I cannot say executing, they are capable to run some stuff in environment. Mm, environment. What does it mean? So it's basically nothing called as tool calling capabilities. So for example, when you ask a normal LLM, let's say some old LLM, right, without any tools or something, just trained on internet data, what is weather in Bangalore today? So it won't know, because training date, last time you would have trained maybe some 2 3 years ago, which doesn't know today's date. And LLM even doesn't know that time, like what is today means. Today is with respect to this today. So then later, they again, with the multiple, with the bunch of releases and research work that they keep doing, they came up with this concept called as tool calling capabilities. So it's basically nothing but LLM is aware of. I think it's better to write. LLM is aware of its powers and just uses them to serve your query. What does this mean? For example, when I ask an LLM currently, like Gemini or ChatGPT, when I ask, what is weather today in Bangalore? So weather API, so definitely, right? So okay, query is, what is weather today in BLR? So this is the query. When I ask this, agent has some tools. Why did I bring up the word agent? LLM has some tools. Um, Weather is one of them. Weather tool, weather API, weather tool. Calendar is one of them. Let's say LLM, the LLM that you are asking this question is having these two tools, weather and calendar. So what does usually weather tool looks like? Uh, you input date, time, and place. I'll give you weather. How is it? So basically, the weather providers, statistical weather providers, might have exposed some APIs, and some of the parameters is like you input date and time and place. Which place do you want to find a weather? It will output an answer. It output a weather condition. And second one is calendar. In order to in order to input date and time, you need to know current date and time. So that also is one of the tool. Maybe you can use simple calendar library or time library in Python. Maybe in that tool, that's what it would have been there. So you pass some information, maybe 3 days back or 4 days back, something like that. It returns you. I'll give you answer. So what LLM would do is LLM knows that there is a calendar which gets me the time which is mentioned in the query. For example, today. So it passes today in query in to query as this parameter, and it will return as today. Wait, calendar tool outputs. What is today's date? 2nd August 2026. Now calendar gives that. Now what is the second thing you want? It knows the location and it knows the time and it knows there is a tool called weather that if you give these two informations to that, it will give answer basically. So if you do weather tool takes in 2nd August 2026 as date and Bangalore as location on outputs weather in some big JSON thing or whatever. So then LLM takes that info along with query and formulates answer. LLMs are always good at this. So you give some text, it gives a lot more text as output. For example, maybe that might be a question or that might be something you want LLM to work on the external data or summarization as I spoke. So this is what is basically, and tool is nothing. It's not a magical thing. Tool is nothing but a Python function, right? Because a function is something that takes input and gives something as output. It's not necessary every function or tool should have input parameters, as functions exist without any input parameters. Tools also in the same way. And with this, I remember I will share something that I did at my work. So LLM LangChain launched the tool capabilities. It was the first time the tool capabilities are launched by the LangChain library. I don't know exactly it's first time in the entire world or LangChain launched, but so my first task at the internship is to create a tool that invokes an API. Basically, the tool need to get the parameters which API is expecting in the payload, and that API returns some of the relevant data to the query, and I have to that should be the tool output, and it should take that. So LLMs by default cannot invoke APIs because invoking APIs uh, is a different thing, but invoking a tool is what LLMs are good at. That's what they are trained at. For example, they after their one stage they would have again does a series of supervised learning or reinforced learning, saying that they would have feed large amount of data for tool input output examples and all the stuff. So that's how LLMs became good at that, and that's how it came. Then came something called as agents. So yeah, so it's basically agents are nothing but Like agent can perform some of the tasks with the help of within agent can act autonomously within its environment. I don't know if this is right or wrong, but I think this is what a non-textual definition should look like. Autonomously perform task its within its environment. So you say you can ask me like, isn't it what LLM is doing? That's as simple as possible. That's as simple as that because agent is nothing but LLM with some environment. When I say environment, it tells tools associated with it or some other stuff, file system to write or something like that. So yeah, after this tool calling capabilities, again most of the frameworks are evolved like LangChain, Langsmith, not Langsmith, LangChain, Langgraph, and multiple stuff. So then came something called as LLM task decomposition and task delegation. So why? So yeah, again, with the how fastly, how quickly the models are released. I think when I was in college, during my placements, ChatGPT has launched something called as O1 preview. They say like earlier it came like ChatGPT 2, ChatGPT 3, ChatGPT 3.5 like that. But for the first time, they launched a model called as ChatGPT O1 preview. It's basically the model with better computational capabilities and problem solving capabilities. And the rest is the story, 4 series, 5 series, Anthropic, Claude, different models. I don't even remember what are the different Claude models, those many models they released. So with all these releases, one thing LLMs became very good at is task decomposition and task delegation. What do you mean by that? So as the LLM's capabilities increased, so as our requirements. So the expectations from these LLM models started increasing. If you see where do we started? We started just doing some summarizations of some of the context we gave or something. From that, we went to RAG. From that, we went to tools. From that, agents evolved. And from that, not from that, within that scope only, within that agent scope only, that LLM task decomposition and agent delegation came in. So, what exactly this is and why does this gain so much traction? So, there is company called Manus AI. There is a product. There is not company. There is a product named Manus AI. It's a Chinese company called from Monica. So what does this Manus AI do? Manus AI is first autonomous general purpose agent. What do you mean? So when you say, for example, what do you mean by this? So you can ask any questions like query will be uh, do a research on available search strategies in internet and provide me a detailed report. So this is very complex query, right? Because a simple tool call or a simple things doesn't do that. If I give you this question, if I give you this question saying that, hey, can you go do a research on different search strategies in the internet and provide and also draft me a report. So what you will do? What humans do here? First, you search internet on search strategies. You search internet on search strategies. For example, you go to Google and you search. Basically, you'll search the exact word, search strategies or whatever. Google gives you some links. You will go to relevant ones. Then you will find out some are relevant, some are relevant. Then you will only narrow down your search to relevant, and then you go deeper, and you gather information. Gather info. Start start drafting a report, and then task is done. This is what a typical human could do. For example, like when I give an assignment to my student or whoever, right? This is what they typically do. And so if you see, when I give you a complex task to perform, you manually by default you try to break it into a simple things, because getting the simple things done in a small pieces and accumulating it together will give you a bigger thing. That's what I think called as divide and conquer. You divide and conquer in data structures and algorithms. It's a technique to solve a problem basically. So it's like you divide a given bigger input into small inputs, and you perform operations at the lowest level possible. Then you keep coming backwards and merge the entire one to get to the final result. Something like that. It's the same thing. So now LLMs also can do the same thing. What LLMs can do? Uh, if you give a query, it can break into different queries, and in order to answer each small queries, small query, there are multiple tools that LLM can use. We'll take a simple example. The simple example might be as simple as what is the weather today in BLR. So, in order to get this answer, you need two things. What is date? What is weather? First, you need to know date before invoking weather API. So you get that, and now you know location and place. You know location and date. You will just invoke the weather API. This is what you typically does, and same thing here also. But Manus is very capable at doing this. Is what they claim, and they have such an amazing blogs, and they are brutally honest. Their engineers are brutally honest on their learnings. They didn't even hesitate to put out their failures as well. So if anybody is interested in all this, you can ask any LLM saying that give me point me to research papers that man has published on context engineering and all the stuff tools in. So yeah, and yeah, I think this is easy, right? You break a task into smaller task and get each simpler task done individually, or even in related case also. Then you combine the answer and get to the answer. So so in this case, Manus does this. Manus agent does this. What is the first thing it do? It says search internet for info. అవి ఒక బ్యాగ్ తెచ్చుకున్నావా? ఒక బ్యాగే తెచ్చుకున్నావా? లోపలికి రా, ఇంకా లైట్ ఆన్ చేసుకో. లేదు లేదు, ఇంకా జరుగుతుంది, పర్లేదు, ఇంకా search internet for info. By the term searching means it gathers also. It's like retrieval. Maybe this can be web search tool. Draft a markdown file .md. This is like file creation tools. Then after invoking these two tools with these three different queries is what you will be able to achieve answer. And it's so many things, right? So let's say if you ask get the stocks of these 6 companies in past 3 months and draw a pie chart comparison of these things are. Let me break down. Let me query example 2. Meanwhile, I want to see how many users we have. Oh, we have 2 users, 2 people. Okay. Uh, what happened to my history? Okay, it's a bad head. So query example 2. So if I ask Manus, uh, here are 6 companies, uh, IBM, Nvidia, Google, etc. Give charts, data, representation in stocks performance per month. So you see how complex this query is. Uh, like when I say this query to human, what they have to do. First thing is search or get 6 companies ka past 6 months data. Group or analyze them on monthly basis. Then prepare or invoke different possible charts. I should not invoke here. So prepare different possible charts. Maybe bar, pie, line, or whatever graphs it is, right? So uh, yeah, after this three, this might be again a subtask. I mean, bed లోపల ఉందనుకుంటా దుమ్ము పడతాను నేను మడతేసి మధ్యలో ఉన్నట్టుంది this alone itself can be split into multiple things, like because each chart tool will expect different parameters. So yeah, each chart tool will expect different parameters. Similar way, if agent Manus, what it does is it breaks this into 3 simpler things. One is fetch 6 companies ka past 6 months data. Second thing is group data or sort data per month basis or something like that. And then for each thing, for each month send data to different charts algorithms or whatever. However, it's done. So basically, this is what exactly task decomposition is. And the second one is task delegation. So what is a task delegation? So let's say I know 3 people. So so let's say I want to make chicken dum biryani for lunch, and I have 3 friends, and they are capable of doing multiple things. For example, one is very good at going to chicken shop, getting good pieces of chicken which is suitable for biryani, because the biryani cut and curry cut is different. And second friend is good at cutting or chopping vegetables and washing rice or whatever. Third guy is very good at assembling everything, putting everything at one place. So when I want to make a biryani, I will call person A saying that, hey, you go get this list of vegetables. Second person, you go get this much amount of chicken or mutton. The third person, I'll tell, once they are done, you have to start making actual biryani. So here I am delegating my main task, that I want to make chicken biryani into a different people, so that at the end, after all the people doing work, the biryani is ready. So that is called as task delegation. Here, how does it play a role? So some agents are specific, some agents are good at performing specific actions, right, because of the tools associated with them. So for example, there is a agent called research agent, which is good at uh, doing research. over web. Second one is documentation agent. Document agent. I'm bad at namings, but pardon me. Document agent, which is good at creating or drafting documents. Third one is review agent, which reviews the content of a document. Yeah, which reviews content of the document. And yeah, third one is something, right? Because each agents are isolated from each of the tools. Well, there may be some overlapping tools like generic tools, but task specific tools are always isolated to an agent. For example, research agent के लिए it wants some web search tool using some Serper API or DuckDuckGo or whatever it is built with. Document agent के लिए it should have tools that uses Microsoft Docs or Markdown Maker or something. And the review is also, it's like it should act like a judge, LM as a judge. Maybe see the formatting, see the relevancy of the information for the headings and the overall document scoring, something like that. This is called task delegation. So if I have a let's say big task like this, and if I break it to different queries, okay, let me write it here. Break a task, or so let's not mention a query, right? Because it's not just a query, it's a task that has to be performed to answer that query. So break a task into simpler task, delegate each task to a specialized agent. I think this is as simple as possible. This is, if you want to, this is, I kept in a very simple terminology. So yeah, it's like break task. How I broke to make a chicken biryani. I want to have veggies required like onion, tomatoes, chili, all the stuff, and masalas. And second thing is I want the main thing in biryani, chicken or mutton. And the third thing is assembling all this with the rice and cooking it with the proper temperature and stuff. And I'm using an individual person who are good at doing individual things. So that's what I'm making use of sub agents, or that's what I'm delegating the task to them. So for this to happen, agent should be aware of, why is my typing is so bad? Agent should be aware of what all agents it has access to or known to. So for example, uh, one agent only knows two agents, but there are totally 5 6 agents that are available, but it needs only two agents to invoke. So yeah, agent should be aware of what all agent to this thing. Second thing is agent should be aware of its sub agents capabilities. So when I want to delegate a task to some sub agent, I need to know what are its capabilities, what are the things that it can do. Uh, so for this, each agent holds a called as agent card. This says its capabilities, things it can do, and tools it has. So when I get so it's basically saying I have an information saying that one friend is good at getting groceries, one friend is good at getting quality or whatever non things for biryani, one more friend is good at in the cooking process. So these are something called as capabilities of an agent and things it can do, tools it has. Maybe the agent, the person who wants to go to groceries may not go in person, may have Swiggy to order groceries home. Same thing with non-veg guy. He will be ordering non-veg from Nando's or some other non-veg vendor. Third thing, the third person just put on in his cooker or induction stove. So that's what it means to be that. So where is it gone? Yeah, things it has. So when an agent want to establish a connection or it delegates, it reads all this information. I know in my memory that these each individual, one of my friend is capable of doing this, but since agent is like computer software, it doesn't know by default. So that's where the communication agent to agent happen, and that's where A2A is born. A2A is the full form is simple. It says in name, agent to agent. It's a protocol, basically that makes one agent to communicate with other and one agent to communicate with its tools as well. So yeah, it's built by Google. Now it's open source and comes under Linux Foundation. If anybody wants to contribute, you are free to contribute. It's such a it's such a good, interesting, not funny, it's such a interesting library. Or is it a library? It's a framework. Yeah, it's a framework, not only a library. Yeah. So yeah, I still struggle with some parts of it because of the abstraction it has. But unless until you care a lot about them, it should be fine. So no, it's not both. No. Yeah. So this is what these are, right? Yeah, this is what these are. The problems. What is the problems? Number one problem the entire world is facing: context. What is it? What is context window, and what exactly? Why does that matter to an LLM? So, how do I tell? Even I don't know even if the information or the knowledge I have on context window is accurate or correct or relevant to the real world. But what I have known from my learnings is context window is what LLM sees, and it sees everything in its context window. When I meant says, it's like process. And the more context window, the more data LLM has to go through its neural networks, and the more that mathematical functions internally has to execute in parallel. And that's why the more consumption of electricity and all the stuff to run this or to do a response to, to process a request. And that's why more tokens are burned, and that's why LLMs cost increases. Yeah, it's simple, right? Context window is what LLM sees. So let's see two cases. What actually how it looks. Uh, Tool message, AI message, all the stuff we'll see with this example. Till now, what you remember will be what I said till now will be sufficient enough to understand what is further. Let me make this quicker. hmm Okay, and here also I'll add two more. Yes. How much time it is? It's already 38. We got four likes. Okay. Yeah. So, yes. Let's say there is a query, right? What is MCP? So, this is a query that I ask an agent. So, now whatever I write is a context window. So, every agent or LM powered application will have something called as system prompt. Basically, it's like you are an helpful assistant and all the stuff. Now you have query. What is MCP? These two will go to LLM. Now matlab these are in context windows whatever. Okay, let me draw an excel draw. How to go to it? New one. Okay, I can simply yeah, I can do this here. So uh, yes, here first content will be query what is MCP. System prompt I'm writing it as SP, or I can write SOS PMPT. Let me. I'm actually a little bit OCD regarding alignment, so bear with me. Yeah, system prompt is nothing but you are a helpful assistant. So basically, this is context window. This is human message. I'll write it as human message. Now, what's in context window, LLM will read this in the first go. What is MCP? It's a question, and it knows the instruction how it should behave. System prompt. Based on that, let's say it has the tools. For example, it has one tool called as web search tool. It has a tool and it tries to invoke that. So I'll write AI message because AI makes LLM makes this call. This will be. I think I should draw this in a circular things. So this will be tool, and the tool name will be web underscore search, and query will be what is response. What is MCP? My bad. What is MCP? Yeah, this is AI message. LLM generates this message, uh, and after reading this goes to a tool a function called as web search function. It may be written in any language irrespective of the language, whatever compiler or environment the model is in, it make use of that particular thing. So it goes to tool node basically in a graph. Imagine that there is a box. Inside that box, there is a tool. If we send it to that box will take care of execution of the stuff. Now something comes as tool message. This will be appended to this actually. Now context window will be okay. I should okay. What is happening? Mhm. Yeah. Now the context window will be user message. AI message. AI message में all this will come. Yeah. Now again, that will get executed and it will come here as an output. I'll write in rhombus. Here it will be MCP's model context protocol blah 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 blah. Yeah, and this is 1 second. Yeah, and this is wait, this is human message, AI message. This is tool message. Matlab tool output. This is also will get appended because LLM has to read everything, right? So this will get appended. Now you will be scared of what your context window will be. Your context window is here. Let's increase it a bit. And here, right. So here, tool message says MCP is model context protocol, blah blah blah, and this is the context window. Now this is the context window. Whatever I have written in square boxes, LLM reads everything inside this in each request. Now while reading it says user asks this, AI tool output, it writes a tool call and tool message this. Now it formulates answer over it and give an answer, structured answer. For this, which diagram should I use? Chumma, I'll write up anything. So it says MCP is model context protocol, which acts like central repo for central repo of tools for all the agents and so on, whatever. Now now you see, so okay, now you know how what will be the flow. So initially you ask same thing, after a message we appended that, and after tool output we appended that. If there are multiple things, let's say here I want to do what is MCP and what is the use of it, or what is MCP and what is A2A. Here one more web search tool would have gone saying that, the A2A is this would have been appended here, and similar output would have been come here, and these two will be appended as a tool message 1 2, like that. And as you see, if there are multiple tool calls, the context window length increases. And why do I say window length increases? That matters is, once the context window length is increasing, because the every time where LLM is required, the LLM has to read the entire context window. Now we'll see where actually LLM burns its tokens during this entire process. So here, first, when you ask query and system prompt, it decides to call in tool, decides to call web search tool. Since it decides to call web search tool, in order to decide, it should understand or read the human message. I don't know why it is not expanding. Yes. So here some cost is involved, and sorry, here some cost is involved. I'll put it here. And second thing is, yes. Here, after putting a message and appending to this, and here no cost is involved because it's just a Python function. No cost, I'll write here. No cost because functions take care of execution. I think this is such a beautiful chart. Like, isn't it? Isn't this very beautiful? Yeah, I'm actually very happy. So yeah, no cost because functions take care of execution. And after a message, it knows that it called this, and then third thing, after knowing this, it has to add to context window. Again, here it has to read everything from start to Bapre. Understand to formulate response to the query. Again, here cost is involved because it has to read everything. Here also it is required because it has to output the token. So basically, at three places, LLM has to do a uplifting or heavy lifting work, which has to go through this thing. If again tool calls are more your context window, this will be very small. This is a very simple question, and so yeah, it keeps loading, and the context window of a typical LLM, at least the LLMs which I use at work, is of 128K. There are so many researchers said this. If you keep expanding your context window, LLM keeps loose of something in the middle or something in the start. It remembers something in the start because there is a system prompt and user query, and end is required because that is where most recent tool call will be there, but whatever in middle will get saturated. LLM keeps losing attention over that. I don't know what that particular term is called as, but that's what that term is defined as. So usually, and in order to do this, in order to save context window, why to save context window? For two things. Let's again come back to our thing. Okay, we saw this, and why context window matters. Context window matter for two things. First thing is what we have discussed just now. Answer quality, which is if more context window, LLM has to process a lot of information, which is bad for it. Answer quality might decrease. Second thing is cost. As I told, I think my Mac charger is good. As I told, since it's reading much information, generating much information, and reading it in multiple turns, is what requires more computation in order to handle that parallel things on GPUs, all the stuff, and that requires electricity and all the stuff like that. Yeah, because of these two, I think these are the only two that we are concerned. One is cost and one is answer quality. I think what Chinese are doing is that Kimi LLM model and all the stuff, Kimi DeepSeek. So they're reducing the cost and increasing the answer quality. Okay, we will discuss that also. Just at the end, I want to talk a little bit about that. And yeah, this is why context window matters. And in next video, I think this will be almost 1 hour stream, so I don't want to extend because again of that thing saying that uh, the starting of my video you'll be interested, and at the end you will be interested. In the middle you'll lose your attention. You don't want to really listen because that's not that much interesting. So yeah, in the next we'll talk about these two concerns and how to improve these two. Meanwhile, I'll also read some of the information, some of the things that have been paused for some time. So yeah, now let's see what actually happening. What is actually happening? So companies like OpenAI, Anthropic, Gemini, they have huge investors Not investors are huge. They have huge invested money. That is why they have. That's why they have huge infra. Infra by that mean best GPUs and whatever is best out of there, RAM, ROM, or whatever, parallel GPU, at most things, all the stuff. So that's why, because of the good infra they get from the good funding, that is how they are doing better on these models, uh, which basically does more cost, better quality answer. That's what the difference you see between free tier LLMs that they provide, any of these three companies provide, or pro subscription models that any of these companies provide, because they basically burns a lot and lot of tokens, because they have gathered a lot of information in order to answer your question very optimistically or in a very good way. In order to do that, they burn a lot of on the backside. That's why they wanna charge you. Chinese companies like DeepSeek, Kimi, which is like Moonshot AI. I don't know DeepSeek company name, but the product name is DeepSeek. What they basically are trying to do is to cheap the cost and increase the quality of answers. So that's what they are doing right now, and that's why Kimi is one of the biggest thing that they have. I don't really care, or I don't really know about the politics happening between that. Like these companies claiming that the Chinese companies are attacking their models, getting the training, that all the stuff. But whatever, ultimately they are able to provide. They are able to solve this by decreasing cost and increasing the answer quality. As an engineers, as a applied AI or generative AI or gen AI engineers, what we are doing is, this is not in our hands, but what is indirectly in our hands is this answer quality. We can improve answer quality by following some of the things that can make best use of context window, not flood everything as I shown in this picture. This is such a beautiful picture, man. So good. Yeah, so yeah, that's what for this video I want to tell. I don't want to drag much. I think we covered pretty much, starting from the very very basic task that enterprises started doing with LLMs, and then RAG, then how they enrolled to tool calling capabilities, then agents, and now the rest is it's a very niche dialogue, the rest is history, but that's true. So this is what it's all about. In the next video, we'll see what are different things that we can do to manage context window, and something called as deep agents, which I'm very very interested on. So yeah, that's it for this video. Ending the stream. Thank you.